Assalamualaikum and good day everyone. So today I will be present about our group project which is retirement completion prediction. So based on the following data, we have to develop a model to predict retirement rates and analyze potential influences. Firstly, based on the question, we have to construct a single decrement table for each causes. Okay, firstly for the health related exits. Among 40 employees, the number leaving due to health issues in each of the 3 years is 10, 6, and 8. So, we have to construct the table. Firstly, for the year X column, represents the 3 years of the study. And the start column shows the number of employees remaining at the beginning of each year. And the exits column indicates the number of employees leaving due to health-related issues in that year. Okay, the next column is the remaining column, lists the number of employees left after those exits. And finally, the decrement probability column calculates the likelihood of an employee exiting in that year based on the proportion of exits of exits to the number of employees at the start of the year. So, we can see at the decrement probability columns for the first year, we can calculate it by dividing 10 over 40 and we get 0.25. For the second year, 6 over 30 which is 0.2, and for third year, 8 over 24 which is 0.33.
Is 6, 8 and 2. So this value represent the exit value for each year. So for the first year is 6, for the second year is 8 and the third year is 2. So to calculate the decrement probability, we need to divide the value of exit by the value of start. So we obtain the decrement probability for the first year is 0.2, for the second year is 0.333 and the third year is 0.125. So this table can help us to understand the relationship between the voluntary resignation of employee over time.
Lastly is the single decrement table for other reasons. This table shows the numbers of employees leaving for other reasons over 3 years. We start with 20 employees in year 1 where 2 employees left, leaving 18 at the end of the year. Similarly, the trend continues for year 2 and 3 where the remaining employees adjust accordingly. So the decrement probability QX prime 3 calculated as the ratio of exits to the starting populations. For example, in year 1, QX prime 3 is calculated by 2 divided by 20 which equal to 0.100, which increasing to 0.250 in year 3 as more employees exist from a shrinking pool. This table highlights how the probability of exit increase over time, providing key insight into employee retention trend.
Next, we move to multiple decrement table. Uniform distribution of decrement in multiple decrement model, UDDMD. So based on the previous single decrement table, we create a table that contains all of the decrement probability for all causes. We can get the QX prime tau by adding each of the decrement probability causes according to each year, and here we get QX prime tau for year 1 is 0.55, for year 2 is 0.644, and for year is 0.705. Next, we use the formula UDDMD to convert SDT to MDT. So the general formula is QXJ is equals to ln 1 minus QX prime J over ln 1 minus QX tau times QX tau. So J is the causes. So for example here, we calculate the QX1 for year 1. So we enter the formula to enter the value to the formula. So ln 1 minus QX prime J is 0.25 over ln 1 minus QX tau is 0.55, time is 0.55 QX tau, and we get 0.1982. So when we are done calculating all of this value, we can create a table that contain X, QX1, which is for cos 1, QX2 for cos 2, QX3 for cos 3, and QX tau the summation of all of the causes, and PX tau is 1 minus the decrement probability. So below is the multiple decrement table by using the formula UDDMD.
Okay, next, we find the number expected to the retirement over the 3 years. Company has anticipated the 90 employee. There is no loss of the employee. At the end of the year 1, we find that the probability of survival is 0.5755. To find the expected value, we times with the 90, that it remind the number employee is 51.08. So, the employee loss in the year 1 is 38.2. The next in a year 2, we get the probability of survival is 0.5351. To find the expected value, we times the remaining at the end of year 1. So, we get a 27.72. So, the employee loss in the year 2 is 24.08. And lastly, for the year 3, we get the probability of survival is 0.5255. To get the expected value, it's same that we need to we use the year 2 that get a 40.57. So the employee loss in the year 3 is 30.15. So based on the table, we show that how the number employee decreasing for the each year.
Okay, this is a graph that we generate based on the table from the previous slide, where it represents the number of employees reaching retirement over the 3 years and also the number of employees lost over the 3 years. Okay, so based on this graph, it shows how the number of employees change over 3 years. So the blue bar show how many employees stay at the end of each year, while the red bar show how many leave during the year. Together, the blue and red bar represent the total number of employees at the start of each year.
Now let's look at the graphical representations of figures. The numbers of employees leaving each year decreases over time, with 38.2 or 39 employees leaving in year 1, 24.1 or 25 employees in year 2, and 13.1 or 14 employees in year 3. This happens because there are few employees left to leave as the year go by. The number of employees still working also goes down, starting with 19 employees at the beginning and dropping to 51.8 or 52, 27.7 or 28, and finally 14.6 or 15 employees by the end of the year 3. This graph clearly shows how the workforce gets smaller each year because of people retiring, resigning, or leaving for other reasons.
Okay, next, we move to the impact of modifying initial assumptions. So for the scenario 1, improve workplace health policies. Okay, suppose health-related exits reduced by 50% in all years. The adjusted decrement probabilities are for year 1, 0.125, year 2, 0.100, year 3, 0.167. Updated survival rates and predictions show that approximately 8 employees will successfully retire, highlighting the significant impact of improved health policies. So, we create the table. As we can see, for the QX prime 1, which is the cost 1, we reduce it by 50%. And for the cost 2 and cost 3, QX prime 2 and QX prime 3, we maintain the value. And we calculate the new QX prime tau for each year. So we get for year 1, 0.425, for year 2, 0.544, and for year 3, 0.542. Okay, next, from the question, we can get LX tau for U1 is 90. So, to calculate the DX tau for U1, we time LX tau for U1 with QX prime 1 for U1. So, 90 times with 0.425, we get 39. To get LX tau for year 2, we minus 90 with 39, we get 51. Okay, for get the DX tau for year 2, we time 51 with 0.544 and we get 28. For LX tau year 3, we minus 51 and 28 and we get 23. So for the DX tau for year 3, we time 23 with 0.542, we get 30. So this is the table, the single decrement table for modifying assumption of improved workplace health policies. Okay, on the right hand side, we have a bar chart showing the retirement rates based on modifying causes of improved workplace health policies over the 3 years. Okay, the chart compares the number of employees retiring versus those leaving for other reasons. As seen, there is a notable decrease in non-retirement exits, particularly in the later years, illustrating the effectiveness of the improved policies.
Okay, now we are going to look at the modifying initial assumption for scenario 2, where we increase voluntary resignation. Okay, in this table, we already fill in the value for decrement probability for scenario 1, scenario 2 and scenario 3, where QX1, QX2 and QX3. So, we only double the value of decrement probability for scenario 2 only, while we maintain the value for QX1 and QX3. So, we can proceed calculate the QX tau and PS tau. After that, we can obtain the value for LX tau, where represent the number of remaining, and DX tau, where represent the number of leaving. So, we start with 90 because the question tell us the total of employee are 90. So, we put a value of 90 at the first year under the LX tau column. So, to get the value for DX tau, we multiply the value of QX tau in year 1 by 90. So, we get 68. So, for the second year, how we get 22 is we just minus 90 minus by 68. So, we get 22 for the second year because the number of remaining we minus by the number of leaving in the first year, so we get the number of remaining in the second year. So to calculate the number of leaving for the second year, we take the value of QX tau in the second year multiply by LX tau in the second year and we get 22. So in the third year, we get 0 because we take the value of LX tau in the second year minus by the value DX tau in the second year, so we get 0. So this table represent the modifying assumption of increased voluntary resignation. So based on this table, we generate a graph of number of leaving and number of remaining over the 3 years. So as we can see from this graph, there are a sharp decline after year 1 with a significant drop in both staying and leaving in year 2 and reaching 0 activity by year 3.
And lastly, let's compare retirement across different scenarios. This table and graph compare baseline retirement prediction with two scenarios. Scenario 1 assume improved health policies, while Scenario 2 involve increased voluntary resignations. In Scenario 1, improved health condition result in few retires with a steady decline in retirement numbers. For example, by year 3, only 13 retires are observed compared to 15 in the baseline predictions. This leads to higher survival probabilities, which, because the probability of employees remaining in the workforce each year increases due to few health-related departures. Thus, it reduces costs associated with employee turnover for the company. Therefore, this suggests health policies effectively reduce retirement numbers over time. However, Scenario 2 presents a contrasting trend with higher resignation rates. Retirement drastically declined to only 11 days by year 3. This scenario reflects a significant shift due to external factors such as better job opportunities. Therefore, the company may face challenges in maintaining stability. So, this could impact productivity and succession planning for the company. In summary, the line graph highlights this pattern showing Scenario 2 with the steepest decline in retirement. Such comparative analysis is crucial for designing workforce strategies, allowing organizations to adapt policies to achieve a balanced workforce compositions and better manage retirement trends.
Okay, next, we calculate the expected number of health-related exits in the second year by using the UDD assumption. Based on the table, we just highlight for the year 2 health-related exits. So, to find the UDD assumption, we submit the data that we need to the formula by using the UDD assumption. We get the Q prime as for the health is 0.2190. After we get that, we can find the expected value. So we get the expected value is 0.57. It is approximate to the 7. So the expected value for the Q prime in the year 2 for the health related is the 7. Okay, next, we want to see the comparison between the actual and the expected exits UDD assumption. For the UDD is 7, for the actual is 6. The comparison is highlight that the slight variations between the observed data and the model prediction. It shows that the expected exits is 7 is aligned reasonably well with the actual exits is 6. Therefore, it shows that supporting the UDD assumption in this case. Okay. Based on that, we can know what the strength and the limitation. The first one is the UDD simplifies the modeling process, making it easier to estimate the decrement when detailed time-specific data is available. The second one is the assumption provide the result close to the actual data. Therefore, the valid is useful. While the limitation for the UDD assumption is the firstly, if health-related exits show significant variability, UDD may not accurately reflect the real-world pattern. The second one is the small difference between the actual and the expected exit is suggest some deviation from the uniformity.